Swayam Prabha. Digital India. Educated India.
So, friends, in this unit of demand forecasting, we are talking about various forecasting techniques. So far, we have talked about three techniques. One is naive method, second is moving average method, and the third is 3 period. This is also 3 period moving average method. And then we are talking about 3 period weighted moving average. And in each method, we have calculated the cumulative forecast error, and in each method we have calculated the mean absolute deviation also. And when we say cumulative forecast error, it tells you that what is your bias in the forecast, whether you are always overestimating or you are underestimating. Here the plus 5 indicate that we are overestimating. My forecast is more than the demand. My forecast is more than the demand. I am over forecasting. I am whereas mean absolute deviation will tell you the magnitude of the error. That means you are away from your actual demand by a amount of 23 units, which is roughly we have calculated around 7-8% you are with respect to 350 demand. So, we can say that you are away from your percentage error we can calculate. So, further we can see that right now I have taken only 15 period and found that my bias is 5 unit. If I take another 15 data more, if I take 15 more data, that is total 30 data, and if you found that my bias has increased, that means I need some correction in my model. If my bias is increasing, then I have to do my correction like this. Here I have taken 15 period data and my bias is 0.5. On the other hand, if I take 30 period data, this bias may increase to this. If I take more data, this my bias is increasing. So, that means I am overestimating. On the other hand, if in the first 15 it is plus, in the 30 this is your first data, and then it becomes a minus also, it goes into the negative, that is the best thing. That means it is not bias, it is fluctuating, and somewhere and then again it is increasing, again decreasing, something like that. If it is moving around the center line, if your bias is moving around the center line, that is the best, that means there is no bias. Okay. So, we have to see that with the help of, so both the parameters are very important. Cumulative forecast error has a purpose to tell the direction of the error, whereas the mean absolute deviation has a advantage or has a purpose to tell you the magnitude of the error. So, CFE gives you the cumulative forecast error, gives you the direction of error, whether overestimating or underestimating, and mean absolute deviation give magnitude of error, give the magnitude of error. Okay. Now, let us take the fourth technique in the sequence, that is most widely used technique, that is called exponential smoothing method. That is exponential smoothing method. Keep in mind, we are talking about the methods for random variation only, where the variations are happening around the mean demand. So, we are taking so far we are not talking about trend, we are not talking about seasonality. We are not talking about trend, we are not talking about seasonality, we are only talking about the random patterns, random variation in the demand. Okay. So, in that context, this is my technique number 4, which I am explaining here. This is called exponential smoothing method. So, here in this case our forecast of the next period is equal to alpha times the demand of the previous period plus 1 minus alpha times the forecast of the previous period, and there alpha is called the smoothing coefficient. Alpha is called smoothing coefficient. Alpha is called smoothing coefficient. If I take alpha is equal to 0.3, then my forecast of the second period is equal to 0.3 into demand of the first period, that is 350, and 1 minus alpha, that is 0.7 into forecast of the first period. I do not have the data here to start the series. I can take the same forecast as the demand. So, 350. So, obviously, it will comes to be 350. Now, I can work out for my subsequent period. Forecast of the third period will be 0.3 into 370. Yes, you are right. 370 plus 0.7 into 350. So, I will get some number. For F4, I will be 0.3 into 340 plus 0.7 into the number which we are going to get here. The same number which I am going to get here, I will put here. So, I will get the forecast of the next period. So, like this. So, in that manner we can calculate the forecast of the various periods, and then same manner we can calculate the forecast error, and then based on that we can calculate the cumulative forecast error and mean absolute deviation. So, let us see, this particular calculation is for a smoothing coefficient of 4. We will also have a discussion how to decide whether I should keep a low value of alpha or I should keep a high value of alpha. We will discuss that, we will take that discussion also. Before that, let us do the calculation part of it. So, my forecast is as we have taken in the previous case 350. Based on this, how I have got is the 358. Forecast of the third period is equal to 0.4 into 340 plus 0.6 into 350. So, based on this I will get the forecast of my third period. Similarly, the forecast of the fourth period will come 0.4 into 340 plus 0.6 into 358. Based on this I can find out the forecast of the various period. And what you are finding here, this is a good number, we have selected 0.4. Based on that I am finding there is no bias, there is no cumulative forecast error. The value of the cumulative forecast error is 0, and absolute mean absolute deviation is 286, 20.4. Okay. Mean absolute deviation is 20.4, and the forecast error, cumulative forecast error is 0. So, that way we can find that this method is also good, though it has a high mean absolute deviation. Before taking a discussion on deciding the value of alpha, just see that this exponential smoothing method which we are talking about, a simple formula of f t plus 1 is equal to alpha d t plus 1 minus alpha d t, alpha 1 minus alpha f t is equivalent to this is nothing but n period weighted moving average, n period weighted moving average. How? Let us see, if we expand this I can do here, let us forget about this, let us do here alpha dt plus 1 minus alpha. What is f t? F t is equal to alpha dt minus 1 plus 1 minus alpha f t minus 1. Now, if I expand this, we will get alpha dt plus alpha into 1 minus alpha dt minus 1 plus 1 minus alpha square f t minus 1. If I further expand this expression, what I will get 1 minus alpha square, and f t will be alpha dt minus 2 plus 1 minus alpha f t minus 2. So, by doing that, let me change the color so that you get a better idea. So, my forecast for the period t plus 1 is equal to alpha dt plus alpha into 1 minus alpha dt minus 1 plus alpha into 1 minus alpha whole square dt minus 2 plus 1 minus alpha square into f t minus 2. If I further expand, you will find dt minus 1, dt minus 2, dt minus 3 continue. Now, if you take alpha is equal to let us say 0.4, what I am going to get? F t plus 1 is equal to 0.4 dt plus 0.4 into 0.6, that is 0.24 dt minus 1 plus 0.4, let me write here 0.4 into 0.6 into 0.6, that is 0.24 into 0.6. So, 0.144, 0.144 dt minus 2 and plus keep on doing that. So, what you are finding? The weights are decreasing. This is your W1, this is W2, this is greater than W3, this will be greater than W4. W4 will be 0.144 into 0.6, okay, like this. So, the exponentially smoothing method is nothing but n period weighted moving average. So, that is the beauty of that formula, small formula. F t is equal to alpha d t into 1 minus alpha f t is gives you the value of a n period weighted moving average. Without having the demand of n periods data, even then we are getting this kind of a without doing the calculation for n periods, we get the results of n period weighted moving average. Now, coming back, let us have a discussion on whether I should keep alpha is equal to 0.4 or I should keep alpha is equal to 0.5 or 0.6 or 0.9 or 0.1. The value of alpha varies between 0 and 1. So, what should be my value? If I keep alpha is equal to 1, let us take the extreme cases. Let me first make this plate clean. Let us take if I take alpha is equal to 1, what will happen to this formula? F t plus 1 is equal to d t. So, this will become your first formula, first technique. What happens here? Whatsoever happened yesterday, you are responding very fast and incorporating that change today. So, if there is a more demand yesterday, you are ordering more quantity today, you are expecting more demand today also. If there was less demand yesterday, you are expecting less demand today. So, your response is very quick, very fast. So, you can give a high value of alpha of 0.9 or something if you deal with innovative items or you want to give a quick response. If you want to give quick response to the changes, you can give keep a high value of alpha. On the other hand, we keep a low value of alpha if I am in an industry where I do not want to give a quick response, just like in a steel industry. I do not want to change my production rates on a day to day basis or this. I will take a lower value of alpha and based on that the smoothing will be there, the previous few periods data is getting smoothened and I will get a smoothen out demand. Whereas, here it is a sudden impacts are coming, whereas here the smoothing impact will come. So, based on this you can based on your again it will also depend upon the personality of the decision maker also. If the decision maker is very proactive, he want to take decisions as and when there is a change, he can take a higher value of alpha, maybe 0.9, 0.8. On the other hand, there is a decision maker who is want to wait and watch kind of a tendency, he do not want to take much risks etc., he can take a lower value of alpha. Okay. Another way, mathematically if we look at, we can do the simulation of this for different values of alpha. You can do a simulation of this for different value of alpha. I can develop the cumulative forecast error and this I can make a table like this, cumulative forecast error and mean absolute deviation for different values of alpha. I can take the value of alpha 0.1, 0.2, 0.3, 0.4 and up to 0.9. and see what is the value of CFP, what is the value of mean absolute deviation here, and based on that I may select that okay, this is the minimum. So, let us select this, this is minimum CFP, minimum absolute deviation, or I can select this as a model. Okay. So, I can select I can design a model based on the simulation exercise also, or I can apply my business judgment also. If I am in a sector where quick response is necessary, I can take a higher value of alpha. On the other hand, in a business where you have to wait and watch, there you can keep a lower value of alpha. Let us see the impact of various values of alpha. The solid line shows the solid line here shows the actual demand. The solid line shows the actual demand. If you keep a high value of alpha, if you keep a high value of alpha, that is 0.55, if you keep a high value of alpha, let me draw with the blue color, then you are finding you are almost catching the demand. Red color is my actual demand and blue color is with the alpha of 0.55. If I take a lower value of alpha, that is 0.35, let me take green color for this. What we found? That you are not matching, sorry, there is some error here. I show blue color, I will draw again. For small portion there is some error. So, I will draw the blue color again here, rather than going like this, it should go like this. For small portion I have made a mistake. So, like this, and I can draw the third line with the help of let us say mustard color. So, I am finding that you are not responding that fast, you are more producing on a normal production rate, and if the alpha is small. So, in that way, with the help of alpha you want to catch up or you want to work at a normal pace, you can decide based on the nature of the business and based on the analysis of the forecast error. There are other measures also, though we have so far we have discussed the two measures forecast error, but there are many more such kind of are there. We have discussed only though two, but I can have average forecast error also, that is cumulative forecast error divided by the number of observations. I can have mean square error also, like here we have taken f t minus d t. Okay, I have taken error is equal to this, and then I have calculated the cumulative forecast error and mean absolute deviation, and I can take mean square error also, that means f t minus d t whole square and summation and divided by n. So, that is nothing but mean square error. The genesis of using this, if the error is 1, the impact is 1. If the error is 2, the impact is not 2, rather it is multiplied 4. It is like this, if you are not able to do the task, you are late by 1 hour, impact is less. If you are late by 2 hours, the impact is not twice, impact is rather 4 times. If you are delayed or if you are wrong by more 3%, the impact will be not 3 times, but it is 9 times, like this 9%. So, that way. So, keeping that means as the error increases, the impact is also increasing exponentially. So, we can take the square error, and we can take the standard deviation also by making a under root of this, then I can take the standard deviation also. Okay, just like we do in statistics, we can take that. I can talk about the mean percent error also. Let us see that also, what is meant by mean absolute percent error. We have tagged out mean absolute deviation. Mean absolute deviation was summation f t minus d t absolute value divided by n. That was my mean absolute deviation. Now, what is meant by mean absolute percent error? This whatever mean absolute deviation I am calculating, I will multiply it by with the average demand, and then multiplied by 100, So, that will give you mean absolute percent error, mean absolute percent error I will get. Why we do that? This is required if that if one stream of demand is just like we were considering 350, 370, 390 and 410, 360 something like that, just like we were doing, and we were finding the error was 30 units, 25 units absolute deviation we were talking about, it was 32 something like that, and then we calculate the mean absolute deviation. If there is another series which is let us say 3500, 3700, 3200, 3100 and or not like this, or let us take something like this 3500, 35, 35, 35, 27, 35, 90 and like this, and then the forecast error is absolute forecast error is of the same order 35, 25, 65, 25, 30 and we are finding the mean absolute deviation is same as in this case, mean absolute deviation of this number and this are same. Can we say that both the cases our error is same? If mean absolute deviation of these two series are same, can we say that in both the cases we are having same error? No, we cannot say, because this error is with respect to a base of around 3500. The percentage error here is only 1%, whereas in this case the percentage error is of the tune of 10% like this. So, that is why if the base is not same, if the average demand is not same, then it is more appropriate to calculate the mean absolute percent deviation for the sake of comparison. Suppose your demand is growing, you want to calculate the forecast error of last 1 month vis-a-vis previous year. The previous year demand was less, this year your demand has increased. So, in that case the two numbers, if you take only mean absolute deviation, it is not comparable. You have to take it, you have to normalize it with the help of average demand, and then you can calculate mean absolute percent error. So, that is the kind of but on the other hand, if the base is same, then mean absolute deviation and mean absolute percent error are both will lead to the same results. So, there is no need of calculating percent error, even the mean absolute deviation is sufficient for us. Now, coming to the tracking signal, this will give you some idea that about the bias and magnitude. Can you tell me in which case magnitude is more and bias is less? This is a case of less bias and high magnitude. You are finding your observations are deviating to a large extent, as compared to this case the observations are very close to this. This is having less magnitude, but few observations are much away, but if you ignore this, you are finding your forecast model is very good of less magnitude and there is no bias also. Now, look at this, this is having high bias, overestimation. You are always overestimating, the actual demand. Okay. And this is also a case which is having a low bias, because your forecast is blue color dots are on the both sides of this, and this has low magnitude also. Okay. Low magnitude also like this. So, we can here the so this with the help of this presentation, with the help of these scatter diagrams, you can visually also see what type of error you are having, whether the error is more or error is less. Visually also you can represent the forecast error and see the quantum of bias and the quantum of magnitude with the help of this. So, this already have explained mean square error. You do the square of this, and mean absolute deviation we have talked about, and then very important parameter which combines the two things, that is cumulative forecast error and mean absolute deviation, which we have talked about. It combined together as one parameter, that is called tracking signal. So, tracking signal will tell you how much is the noise in the system and how much is the signal in the system. Okay. So, tracking signal will give you the noise and the signal of the system. With the help of this tracking signal, you can, this is a ratio of cumulative forecast error and mean absolute deviation. If your cumulative forecast error is high and mean absolute deviation is very less, that means noise is very high, tracking signal, you are having more bias into the system. On the other hand, if your numerator is low and mean absolute deviation is high, that means your error is on both sides, but the magnitude is high. So, in that way, with the help of the tracking signal, we can predict what type of my forecast model is. So, we can plot it also, and we can take the concept of control limits. We will see that tracking signal is within control. If the tracking signal is going outside the upper control limit or outside the lower control limit, then that is a warning sign. Then that is a warning sign that if it is exceeding, that means your bias is much more as compared to the absolute error. You are biased, you are overestimating or you are underestimating. Okay. If it is going below the control limit, that means you are underestimating to and if it is going above the upper control limit, that means you are overestimating, your bias is more, cumulative forecast error is more as a percentage or as a fraction of absolute deviation. So, very important parameter to see the quality of your forecast method. Now, come to the exponential smoothing method with trends. So far we have taken the random variations. Let me explain again, just to recollect the previous models which we have studied so far, that is this 3 period moving average, it is popularly called written, then 3 period weighted moving average, and then exponential smoothing method. Okay. These 4 methods we have studied, and these 4 methods belongs to the phenomena of random variations, where your demand is fluctuating around some mean value. So, here we are talking about trend, here we are talking about trend. So, this is only random. So, these method which we have studied so far belongs to this category. Now, let us see the trend aspects. In case of trend, as we discussed earlier, the demand is not straight line, but the demand is increasing. This is time versus demand graph, and not straight line, around that your random variation is there. So, there are 2 types of variation, one is there is a trend and second is there is a randomness. And further, before moving forward, let me explain you one small concept which we are going to use in our calculation. Though I have said that your trend is like this, in actual this trend may not be like this. In actual, sometimes there is a steep slope, there is less slope, there may be decline also, there may be. So, even this trend itself is also changing. Sometimes you are having a increase in demand by 10 units, sometimes there is increase in demand of 20 units in certain period. Then another period it may come down to 18 also, it may come down to 15 also for certain period, or this increase may not be constant, or it may go like this also. So, we need 2 smoothing coefficients, we need 2 smoothing coefficient, one smoothing coefficient alpha to smoothen out this random variation, alpha to smoothen out the random variation, to smooth the random variation, and we need another smoothing coefficient, that is beta, to smoothen the trend, to smoothen the trend variation, trend is not always that in every period the increase is 5 units per period or 7 units per period. It is sometimes increase is 5 units per period, sometimes 7 periods, some units per period, sometimes 3 units per period or so on. So, you need a another smoothing coefficient to smoothen the trend of different periods. Okay. So, that is why in this model we will use two smoothing coefficient, one is alpha, second is beta, but both alpha and beta are between 0 and 1, beta is also between 0 and 1. So, they are smoothing coefficient, one smoothing coefficient alpha is for random variation and beta is for trend smoothing the trends. Okay. So, with this discussion now let us see on the slide. The previous model smoothen out the random variations only, none deal with the upward or downward trends as I have explained, and to do this we will add a trend component into our exponential smoothing model. So, we will use two smoothing coefficients alpha and beta. Let us see with the help of one example. So, here we are having our forecast demand is equal to the trend the random adjusted as well as the trend adjusted. So, two things we are going to adjust here, the trend estimates t plus 1 and unadjusted method means random only, and then adjusted for a trend, and together will give the trend adjusted forecast error. So, in that way I can say AF is trend adjusted forecast error and whereas FT is without adjusted unadjusted forecast, and TT is the adjustment for trends, So, like this, and two coefficient alpha and beta, this smoothen the noise and this smoothen the random noise in the trend, and this smoothen the random noise in the baseline demand. Okay. So, two smoothing coefficient alpha and beta we are using here. Let us see one demand scenario. This is my data and you are finding that in period 1 the demand was 31 and it is increasing. If I plot the graph, you will find that if it is time versus demand graph, in period 1 the demand is, let us say mark this 30s, 40, 50, 60. So, period 1 demand was 31. So, this is 30, this is 60. Period 2 the demand is 40, something like this. Period 3 the demand is 43, period 4 demand is 52, period 5 demand is 49, it can go down also, and then 64 somewhere here, 40, 50, 60, I have to take 70 also, and then in the next period it is 58 slightly going down, and in the next period it is 68. So, my trend demand is something like this, So, it is increasing, in between there is some decline also. So, like this. So, this is there is a fluctuation, there is a demand which is varying like this. So, let us see the forecast for the period 2 from this data, and alpha we are taking as 0.5, alpha we are taking at 0.5 and beta we are taking at 0.3, and based on that we will calculate this alpha AT plus 1 minus alpha AFT. So, we will calculate this, and trend adjusted for period 2 is equal to 0.3 into 31 minus 28 plus 0.7 into this. So, T2 is my trend adjusted estimate is 3 and unadjusted forecast is 31, and together the forecast of the period 2 will be 34. The forecast for the period 2 will be 34, and like this I can calculate the forecast for various periods. Starting here I will keep the same number as here, but in period 2 the forecast is 32, in the period 3 forecast is 40.9, period 4 like this. So, this is adjusted, this is unadjusted, and this is the adjustment for trend. So, this is there is a increasing trend. So, all my adjustments are positive in nature. If it is a declining trend, there may be these numbers may be in minus negative. So, what are we are finding? The error 40 is my actual demand, forecast is 31, and here the forecast is 40. So, error is less. Here it is 43, 37, 40.9, error is less here. 52, 42, 46. If I am not adjusting for a trend, the error is more. If I am adjusting for the trend, the error decreases. So, that is the point which you have to note it down. If there is a trend in the in the demand and you ignore that trend, if we ignore this particular trend, that means my error will be more. But if you take care of the trend and adjust for the trend, you are finding your error is reducing. The forecast error is reducing, your forecast is closer to the actual demand. Your forecast is closer to the actual demand. So, we can see graphically also the black color shows the actual demand and pink color shows the adjusted forecast. The pink color shows the adjusted forecast, and if on this I draw the unadjusted forecast, pink color is unadjusted forecast. In the previous slide is the pink color is unadjusted forecast, and then here we are having adjusted forecast. You are finding that adjusted forecast is closer to the black color line, which is the actual demand. So, that is how if we adjust it for the trend, our forecast accuracy increases. On the other hand, if we are not adjusting, our error is more. Like here, this is the error we can measure. The error is small here, error is more. Similarly, here error is small and error is more. Similarly, here we can see that the error. Okay. Here pink color is rather matching. So, here it is a slightly opposite, but in most cases you will find that error is less with the orange color as compared to the pink color. Okay. Few exceptions are there, like here there is exception, there is an exception, but overall we are finding adjusted forecast is better than the unadjusted forecast, because there is a trend and you are ignoring the trend. In the unadjusted forecast, you are ignoring the trend, whereas in adjusted forecast you are taking care of the trend which is existing. Now, come to the seasonality items. The last model in the time series case, the adjusted the seasonality products. As I said, seasonality at a dry cleaning shop, air conditioners, tourism at a particular place like in hill station, etc. More tourism in the summers, less tourist in the winter, and maybe other places also there is some kind of a or another way is tourism in vacations, etc. When the students are having vacations, the traffic is more, at other period the tourism is less. So, that is the kind of seasonality we can see at various tourist places. So, how to forecast for the seasonal items? Let us do with the help of one example. Let us say this is the data of a dry cleaning shop. You can call it air conditioners also, you can call it for a tourist place also. For a tourist place, number of tourists which are visiting, maybe in this number or maybe some multiplier of this number, maybe 5,000, 17,000, 50,000 to 28,000, something like that you can consider. So, this is the data we are having for 4 years. 4-year data is with us about the demand of about the demand of a particular item. Demand can be of a tourist place, demand can be of air conditioner, demand can be of a dry cleaning work. And quarter wise there is a data is available for different quarters. This is a lean period and this is a third is the peak period. We are finding that demand is less, then it is increasing, then again increasing substantially, further reducing and again reducing, and like this it is further reducing. So, like this the demand is reducing. Second trend which we can see, there is a trend also. The total demand of year 1 is 1000, total demand of year 2 is 1200, total demand of year 3 is 1800 and total demand of year 4 is 2200. So, we can see that if we want to see graphically, we can see that there is a seasonality as well as there is a trend. There is a seasonality as well as there is a trend in this demand variation. We do not have the fine data of different days, then if we have the data of different days, we will find that they are fluctuating around that also. Along with this two variation, we are having some random variations also. Here we are not talking about that, we are considering trend as well as seasonality in the demand. So, let us see that. So, step 1, if we see the procedure, we will calculate the seasonality index of all the periods. We will calculate the seasonality, like seasonality index for year 1 quarter 1. Seasonality index of year 1 quarter 1 is equal to 50, that is the actual demand of that period divided by the average demand of that particular year, average demand of that particular year. So, you will get 0.20. So, this is how. Similarly, for seasonality index of year 1 and quarter 2 will be 170 divided by 250. Seasonality index of year 1 and period 3 you will find 500 divided by 250, like this. So, in this manner we can calculate the seasonality index of all the periods for which we are having the data. For all these periods for which we are having the data, we can calculate the seasonality index. So, this I have written here. I have copied this, just like we calculated 0.20, 0.68. 0.68 will come 170 divided by 250. How this 2 will come? 500 divided by 250. 1.12, 280 divided by 250. So, like this. Similarly, if I look at here, how I will get 0.45? 0.45 I am getting is coming by 250 divided by 550. 250 divided by 550 will give me 250 divided by 550 leads to an answer of 0.45. Okay. So, for all the 4 periods I have calculated the seasonality index. Now, I will calculate the average seasonality. Average is average of these 4 numbers. So, 0.38 is coming 0.20 plus 0.43 plus 0.44 plus 0.45 and all divided by 4. So, that gives me a number 0.38. Similarly, for quarter 2, this is for quarter 1, this is for quarter 2, this is for quarter 3, this is for quarter 4, and like this I am getting the average seasonality of different quarters 0.38, 0.79, 1.86 and 0.97. So, average total is 4. Okay. Now, go to the next step. Now, based on this, if I know that my let us say demand of the 5th period and let us say the total demand of the 5th period is 2600. If from this trend I estimate what is my demand forecast of 5th year, let us say this is 2600, then the average is average of this is we can calculate 2600 divided by 4, 650 units. So, what I will do, whatever average I get, I will multiply this with 650. I will multiply these numbers with 650. So, 650 into 0.38 is 249, 650 into 0.79 is 512, 650 into 1.86 is 1207, 650 into 0.97 is 631. So, and total is 2600. So, this is how a quarter wise forecast I can made for this seasonal item based on this particular calculations of seasonality index, and then casting forward for the 5th period I can forecast, and based on that I can forecast quarter wise the expected demand for different quarters. Let me erase from this. So, if the forecasted demand of the 5th period is 2600 unit, the quarter wise forecast is we can calculate, average is 650 as I have said. The forecast of quarter 1 year 5 is 650 into 0.38 is 249. So, friends, this was the seasonality model, and which we had talked about here, and softwares are also available on this for classroom teaching also, as well as for obviously now we are having ERP with us, data ERP enterprise resource planning data is there. In that there is an inbuilt function for forecasting resource planning. ERP softwares, every organization is now, even small and medium size organizations are also have implemented ERP, and based on that they capture the demand of the previous periods, and inbuilt macros are available. With the help of that you can forecast the demand of various periods. So, based on forecast ERP also we can do that. Now, what are the limitations of these techniques of time series forecasting? This is the limitation of the forecasting model. One is these techniques work fine if the past demand is a good indicator of the future demand, but how to consider the following situation? If there is some major client is added into it, or there is some other disturbance or disruption may take place. It can be positive, it can be in a negative manner also. So, how to account for that in our forecasting, that is not there. So, maybe that I will get an idea about that if there is some subjective event, if there is some event which is not in the scope of the time series. As a decision maker, as a forecaster, I can moderate my forecast which is coming through the time series forecasting. I can moderate it for the factors which are external to the time series. So, all factors which are external to the time series, I can consider them externally as a forecaster, as a decision maker. I can include that, I can moderate my results of time series analysis. Or there is some major change in the service mix or customer mix. Suppose you are serving a particular community or particular market. Now, your customer mix has changed, you have diversified to other new geographies or new markets, or you have discontinued certain previously served markets. So, there is a change in the structure. So, these are all external changes. If there are some external changes, how we should account for in our time series model, because these are external. So, we have to include them in an external manner only. Then there may be some economic or regulatory change can be there, just like there is a sluggishness in the economy. We have seen that during COVID time there is a drastic decrease in the demand of automobiles. So, if we are using the time series models of previous years, during COVID period this is not going to work. So, that is external factor. So, I have to consider that. So, or there may be some other factor of external nature which may have come. So, that may affect the demand. So, for these some kind of factors which are external, In that case, we can use some kind of a causal models also, where we can say that okay, my demand is not just a time series, it is also getting fluctuated, it is also getting influenced by certain other external factor, which is independent factors. So, in our next subsequent technique, we will talk about those independent factors, and we will how to consider them in forecasting. These external factors can be, as I was talking about in earlier, the car sales. That car sales may get affected by GDP growth, it can be rate of interest on loan, or it can be some other factor which is a macro factor. So, we call them as independent factors, and the sales of car depends upon that, that is a dependent factor. Okay. So, in that case we can consider these external factors. You are using the time series in a normal manner, but you are finding there is some drastic change has happened, just like in COVID period, just like in other scenarios, then we have to consider them with the help of causal model. Let me give you a small concept here, which is very important, we must understand. It is called VUCA. If there is a volatility in the market, how these forecasting models are going to work? If the market is highly volatile, if there is a uncertainty in the market, then how to forecast the demand of our product? And if there is a complexity, you are not able to make out why your demand is changing from period to period, what are those external factors, what are those independent factors, you are not able to capture, or there may be large number of independent factors which are influencing the demand of your product. So, that is or there may be ambiguity, customers mood, you do not have the item is new or innovative, and you are not clear, there is a very ambiguous environment, market is there, and there may be some other brands are there, government policies are also changing, are not very clear. So, in that kind of environment, where the marketing environment is very ambiguous because of customers, because of government policies, because of competitors, or because of non stabilization of the prices, or the product is not stabilized as it is an innovative product or something, the market is ambiguous in nature, or it is complex, there are large number of other independent variables are influencing not only the time series, your previous demand which is influencing your coming period demand, there are other independent parameters which are affecting the demand of your product. So, in that case complexity is there. So, this is we call it VUCA environment. So, how to make a forecast in that? That is a very challenging job for all the business heads, marketing heads, strategic heads, how to consider that. And one important way to handle this, if you are having good quality information with better IT, as I said, with better ERP system, with better data capturing system, you can have you can get to know about certain things, you will be able to find out the patterns because of this, you will find out unearth the impact of these volatility, uncertainty, complexity and ambiguity in the demand pattern. If you are having some idea about that, information is going to play the very important role. Another impact of information is which you have to understand is suppose you are talking about the demand of forecast of a period t plus 1, and if you are having a good quality of data of your previous period, just I was talking about, you have launched a new product into the market, and as the period increases, the quality of your information data is increasing and your forecast is improving, and that quality of information is very important, which you can get with the help of information technology. If this information is coming at a time lag of 10 days or 15 days or 1 month, that means you will lose that particular opportunity of improving your forecast. On the other hand, a good information technology system, maybe we call it point of sale information. if the retail register, cash register is connected with your production planning department, with your forecasting system, whenever there is a sale of your product at any of the outlet of a particular size, of a particular color or of a particular model, immediately if that information is coming to you without any lag, whenever there is a sale, point of sale information is coming to you electronically, digitally, then that is the best thing. So, that based on that you can keep on improving your forecast, and based on that you can take a better decisions about manufacturing, about dispatches, about marketing strategies, about giving the quantity discount, price discounts, off season discounts, etc. You can manage your channels in a better manner if with the help of information technology, if you can do that. Second important function, let me erase this. Second important function which information technology can help you, you will find that as the time interval between the decision and the event, you are taking the decision here and event is happening here. One is, if that time is more, the uncertainty is also high. As this time increases, the uncertainty also increases. Uncertainty in that is proportionate to, I can say, is the sigma of demand is proportionate to the time, the time period between, or lead time, or this is proportionate to the lead time. Higher the lead time, more is the variability in the demand we will observe. So, with the help of information technology, I can cut down this time, decision time, I can bring this decision time close to the event. So, my time is reduced and my uncertainty is also reduced. So, that is the best part for innovative products. You should take the decision as close to the event as possible, and so that your uncertainty is reduced and your quality of decision making, quality of forecast is enhanced. So, external factors are always there. It is not simply the carrying forward of your previous data time series models, which are going to play in your favor. You have to keep again you can also consider what are your leading factors. There may be some indications coming from the market. Your time series data is a lagging indicator. Something has already happened and now you are trying to lagging factors, lagging indicators. You also look at some leading indicators. If people are expecting that there is going to be a good export business from western countries, or there is some problem in the China. So, that is why you are expecting those orders also coming to India. So, these are some of the leading factors, or these days we are using the social media also, analytics of the social media. Posts are coming where people are expressing their views on the social media, and we can use that with the help of data analytics. We can analyze your social views, and based on that these can act as a leading indicator. These can act as a leading indicator. Something which is coming from some external sources, as I said, for export, or there may be going to be some just like we are finding some inflation is very high. So, in that case there may be going to be a reduction in the demand, or there may be some impact on the interest rate, etc., or government policies with respect to taxes, etc., that may affect it. So, we should capture the leading parameters also, along with the taking the time series, which only talk about the lagging parameter, something which has already happened, and leading parameter something which is yet to come. So, a good forecast will come if we can include the leading factors into our forecast. After doing the time series analysis, we superimpose the impact of these leading parameters to get a more normalized, rationalized forecast. So, in the next class, in the next session, we will talk about these causal models, where the demand of my product is influenced by, caused by some other independent variables. These independent variables can be leading parameter, or they may be a lagging parameter, but they are independent to my organization. They are external to my organization. So, with this we close this particular session. Thank you.